Okay, kids, welcome back to another exciting adventure of the Ballistic Pendulum. Okay, last time we saw a bullet collides inelastically with a block and shoots the block up through some angle. We saw for the angle and saw that it was 12.74 degrees, which is less than 15. Usually that's a good approximation to oscillatory motion, which means this thing would just go back and forth with no friction forever. As an aside, I did put down that you can, since it's 12.94 degrees, usually it should be in radians. I'll let you guys convert that. You can use the sine theta approximation, where sine theta is roughly equal to theta in radians, so you can solve for your period and stuff like that. All right, that we will discuss in the live screencast. Okay, let's take a look. So this bullet, before it collided, had some kind of momentum / kinetic energy. Where did that momentum and kinetic energy came from? Came from the ballistic gun, which is also integrated into the ballistic pendulum. Say, well, we had a spring, so let's find out what the problem is. Find the theoretical distance x that the spring, the theoretical distance x that a spring with k equal to 2.5 times 10 to the 4 Newton meters needs to be compressed for it to launch a bullet that's supposed to be at its initial velocity, of 500 meters per second. Alrighty, so this had some final kinetic energy. And where did that kinetic energy come from? Came from the work done, or the potential energy of the spring. So our goal is to find x compression. So E0 equal to E2 plus the work done by friction. In my theoretical system, I just assume that there is no E loss. I just say 0 for now. This will come back later. Underneath, since that's gone, each E0 is a K0 plus U0. E2 is a K2 plus U2. There is no potential energy over here, so I took that out. Bullet here was initially at rest. I took that out. So putting Kx over 2 is mvi squared over 2, and canceling the 2's, I solved for x and yielded this. So let's take a look at the dimensional analysis, make sure that's correct. A little dimensional analysis. So I look, I have the square root. I should get meters. So I get kilograms. I think K has the Newton meters, and I think that's kilograms per second squared, still under the square root, sorry, times, oh, that's gone. Yoink. Times meters per second. These cancel. This flips up. The square root gets rid of this, so I can get rid of that. And my unit analysis or dimensional analysis checks out. Okay, let's plug in some values. So square root of 0.001, it's 1 gram, divided by 25,000. That's going to be a small number, times 500, and these will have the units of meters. So taking a look, control square root, control division. So we have 0. Hello. Nice to see you, Mr. Syntax. 0.001 divided by 25, 1, 2, 3. Your amount times 500. Wow. Looks like 0.1 meters will become 10 centimeters. Going back, my x compression distance, I'll put it in both meters and meters, is 0.10 meters or 10 centimeters, which is rough. That's pretty reasonable. It's like 3 or 4 inches or something like that. It's not too bad.